In this video, we're going to look at Venn diagrams. In order to look at them closely, we need to learn the terminology. U stands for the universal set. That means everything in the Venn diagram. A stands for everything in the circle marked A. B stands for everything in the circle marked B. The N stands for the intersection, and another word is and. The U stands for the union of the two sets, and that another word for that is or. A with a little dash above it means not in A. In other words, it's the complement of A. And B with a little dash means not in B. So if we look at the first diagram, I want to shade A intersection B. If we let A stand for apple and B stand for bananas, A intersection B means I want to know everybody that likes apples and bananas. And this is this section here. It's the only part of the Venn diagram where people like both apples and bananas. In this diagram, we want to shade A union B. In our apples and bananas analogy, we want to know everybody that likes apples or bananas, or both. So that is all this. So everybody here likes apples or bananas, or some of them like both. In the third diagram, we're only interested in people who like apples. So as long as they like apples, we want to know about them. So this is everybody that likes apples. In the first diagram, we want to shade not A. So we want to know everybody who doesn't like apples. So here, don't like apples. All the way outside. In here, don't like apples. So everywhere here. So it is everybody apart from anybody inside of A. In the second diagram, we want to know A intersection B, not. So we want the opposite to A intersection B. Well, we know A intersection B is the inside, so A intersection not is everything but that. So it is all this. In the first diagram, we want A union B not. In other words, we want to know everybody who doesn't like apples or bananas. So it's everybody on the outside. So all the way around here. So this is basically the opposite of A union B. In the second diagram, we want to know everybody who likes apples and doesn't like bananas. Well, that's here. These all like apples, but they don't like bananas. In the first diagram, we want to know not A intersection B. That stands for everybody who don't like apples and do like bananas. So everybody here don't like apples and they do like bananas. In the second diagram, we want A union not B. That stands for everybody who likes apples or doesn't like bananas. And this is everybody here. They all like apples or don't like bananas. So all the way round the outside. And that's it. The only bit left is those few left who only like bananas. Now we can go through some typical exam style questions that use Venn diagrams. Question 1. A and B are events such that the probability of A is 0.24, the probability of B is 0.73, and the probability of A union B is 0.84. By drawing a Venn diagram to illustrate these probabilities, find 1. The probability of not A union B, 2. The probability of A intersection not B, and 3. The probability of A intersection B not. The first thing we need to do is find the intersection, and we can do that by using the formula. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So let's put in what we know. We know that the A union B is 0.84. We know that the probability of A is 0.24. Probability of B is 0.73 minus the probability of A intersection B. If we rearrange that, we get the probability of A intersection B is equal to 0.24 plus 0.73 minus 0.84. So the probability of A intersection B is equal to 0.13. Now we can fill in our Venn diagram. So we know the intersection is 0.13. We know that the probability of A must add up to 0.24. So that makes this bit 0.11. We know that the probability of B must add up to 0.73. So that makes this bit 0.60. And the bit outside, which is left, because this adds up to 0.84, is 0.16. Part 1. The probability of not A union with B is equal to everything 0.13 plus 0.6 plus 0.16, which equals 0.89. The probability of A intersection not B is equal to 0.11. Part 3, the probability of A intersection B not is equal to 1 minus the intersection, which is equal to 0.87. Question 2. A, B and C are three events with the probability of A equaling 0.2, the probability of B equaling 0.25, and the probability of C equaling 0.6, and the probability of A intersection C is equal to 0.08. A. Given that events A and C are mutually exclusive, and that events A and B are independent, draw a Venn diagram illustrating the probabilities. Right, there's two very important pieces of information there. We are told that A and C are mutually exclusive. That means that there is no intersection between A and C. And we're also told that A and B are independent. If they are independent, we have a formula for that in the formula booklet. The probability of A intersection B is equal to the probability of A times the probability of B for independent events. So I'm going to draw a Venn diagram with 3 circles using the information that I've been given. So the Venn diagram I've drawn is shown. I've got A and B, they have an intersection. B and C have an intersection, but A and C do not. I'm also going to use the independent events formula, so the probability of A intersection B is equal to the probability of A times the probability of B. So the probability of A intersection B is equal to 0.2 times 0.25, which is equal to 0.05. I'm going to fill in my Venn diagram now. So I'll put in the 2 intersections first. So A intersection B is 0.05. A intersection C is 0.08. Now that whole of A needs to be 0.2. So seeing as there's 0.05 already, this must be 0.15. The whole of B needs to be 0.25, but there's also already 0.8 and 0.5. So this bit must be 0.12, and the whole of C must be 0.6. Seeing as we've used up 0.08, this bit must be 0.52. What is left is the outside. If you add all this up, it comes to 0.92. So outside is 0.08. Part B, find, part 1, the probability of not in A intersection with not in C. So it is not in A and not in C. Well, that is 0.12 plus 0.08. 0.12 plus 0.08, which is equal to 0.2. Part 2. Find the probability of A intersection not B union C. This means in A and not in B, or in C, which is equal to 0.15 plus 0.6, which is equal to 0.75. Part 3. The probability of not in A union with B intersection C not. So this means not in A or not in the intersection of B and C. Well, that is absolutely everything in the Venn diagram. So the probability is 1. Question 3. In a group of 20 girls, 13 take history and 8 take economics. 3 girls take both history and economics, as shown in the following Venn diagram. The values P and Q represent number of girls. A, part 1. Find the value of P. Well, we know, because we're told, that P plus 3 is equal to 13. Therefore, P is equal to 10. A part 2. Find the value of Q. Well, we know there are 20 girls altogether. We know that 8 take economics. Well, there's 3 in the intersection, so that makes 5. We've already found P is equal to 10. So that leaves us with 10 plus 5 plus 3 is 18. So Q must equal 2. Part B. A girl is selected at random. Find the probability that she takes economics but not history. Well, there's 8 girls that take economics together, but only 5 of them take economics and not history. So the probability of economics but not history is equal to 5 out of the 20, which is equal to 1/4. Question 4. A group of 66 people went on holiday to Hawaii. During their stay, 3 trips were arranged: a boat trip, B, a coach trip, C, and a helicopter trip, H. From the group of people, 3 went on all 3 trips. So that is there. 16 went on the coach trip only. So that is there. 13 went on the boat trip only. So that's there. 5 went on the holiday helicopter trip only. So that's there. I'm going to go to the bottom now. 8 did not go on any of the trips. So that is outside. So X went on the coach and the helicopter trip. Coach and helicopter is there. 2X went on the boat and helicopter trip. Well, that is there. So that's 2X. And 4X went on the boat trip and the coach trip. So that is there. I know that all of those added together add up to 66. So therefore, 66 is equal to 3 plus 16 plus 13 plus 5 plus 8 plus 7x. Therefore, 7x is equal to 66 minus 45. Therefore, 7x equals 21. So x equals 3. Now, fill in the missing bits. X is equal to 3. So 2x is equal to 6. And 4x is equal to 12. Part B. Show that x equals 3. Well, I've already showed that x equals 3 on the diagram. C. Write down the number in B intersection C. Well, B intersection C is this area here, which is equal to 12 plus 3. So B intersection C is equal to 15.